Section 11.3, area of circles. Something you should be pretty familiar with over probably the last couple of years. You've seen a number of times. Circle, we've talked about the different parts, radius, diameter. We've seen many different things about it. Here we focus on the area. Radius, remember, goes from the center point to the edge of the circle, so we can call it. So area, pi r squared, where r represents the length of the radius. We've also talked before about circumference being pretty much the perimeter of the circle, but we give it the nice fancy name of circumference because it's not a polygon, which is pi times the diameter, or 2 pi times the radius. Double the radius, you get the diameter, works out to be the exact same thing. So basically, just a real basic example here, you've got a circle, you've got a radius of 6, so if my formula is pi times the radius squared, I'm going to square the 6 and get 36. Now, typically I would multiply that by pi, which in times, if you need to approximate it, you can use 3.14 and go ahead and multiply it out. Here, if we want to have an exact answer, we don't approximate anything, we don't round anything, we can leave the pi symbol there as part of the answer. So the area is just 36 pi, and then of course, square inches. I'm talking about area, we're always going to have squared units. Circumference, pi times the diameter. If the radius is 6, the diameter has to be 12, so our circumference is just 12 pi inches. So we've got our area and circumference. All right, pretty basic. If we move into some harder examples, where maybe we start to take a look at the area of shaded regions involving circles. Here we've got a small circle within a larger circle, where the radius of the bigger circle is also the diameter of the smaller circle. So to find the area of the shaded region, I'm going to find the area of the larger circle and subtract from that the area of the smaller circle. You can see here it says area shaded equals the area of the big circle minus the area of the small. So the radius for the big circle we know is 8 centimeters. So pi times 8 squared minus, this is the diameter for the small circle, which means the radius has to be half of that. So our radius is 4. So if we square 4, we're in at 16 pi. The area of our big circle is 64 pi. Now, because both have the pi symbol, it also works like a variable, although it is an actual number. All right? If I have 64 pi and I subtract 16 pi, that does in fact give me 48 pi. Thinking in real terms, if I give you 64 pies, and then somebody takes 16 of the pies, you've got 48 pies left over. Square centimeters for our units. Okay? So as long as they both have pi symbols, you can go ahead and subtract. Down here, our last example for the day, we've got a square. Don't laugh at my drawing. We've got a square built into a circle. Again, we want to find the area of the shaded region. So we want to take the area of the circle and subtract out of it the area of the square. We know that we've got a radius of 10 meters. Well, if I double up that radius, that gives me the diameter, which is going to be 20. Since this is a square, I'm going to have a 45, 45, 90 right triangle. Knowing that, that would allow me to figure out the length of the sides of the square. So if my hypotenuse is 20, to go from the hypotenuse back to a leg, I'm going to divide by a radical 2. So if I take 20, divide that by the square root of 2, that's 20 radical 2 over 2, which is 10 radical 2. And so this is the length of one side of my square, which means it's the length of all 4 sides. So the area of the circle, radius squared, so 10 squared times pi, gives me 100 pi. A square, just base times height, 10 radical 2 times 10 radical 2. We know that 10 times 10 is 100. Square root of 2 times the square root of 2 is 2. So when we take 100 times 2, we come out with 200. And so this becomes my exact answer. 100 pi minus 200 square meters. If you want to approximate, obviously we could just multiply out the 100 times pi, then subtract 200, and then you've got your approximate area. But for an exact answer, this works just fine. All right, so hopefully that helps you out with some of the other problems you may be looking at in terms of area. we'll see you next time.